Two ships leave port at the same time. One sails south at 15 miles per hour, and the other sails east at 20 miles per hour. Find a function that models the distance d between the ships in terms of the time t, in hours, elapsed since their departure. We can draw a bit of a diagram here. If this is the port that we start from, one ship is sailing south at 15 miles per hour, and the other is sailing east at 20 miles per hour. So we've got our ships, which I am giving very crude drawings of. Maybe there's sails on them and we're looking from above, and I don't know, I'm not an artist, I am a mathematician. My drawings are going to be awful. Please feel free to laugh at them. Anyways, the distance between those ships will be represented by this distance. And what sort of a shape do we get? Not just a triangle, but we get a right triangle that represents the distances between the ships and the port, as well as the distance between the ships. Now, we want to know this distance between the ships, and we want to know it as a function of time t. So we want to write distance as a function of time. Now, in a right triangle, we know that we have the Pythagorean theorem, which gives us the relationship between the three distances. So what we actually need is each of these shorter distances as a function of time as well. So let's take a look at the ship that's sailing south. It's moving at a speed of 15 miles per hour. Now, to find the distance after a certain amount of time, we have the relationship distance equals rate times time. Now, in this case, we are moving at 15 miles per hour. That's the rate or the speed. And the time we're told is t. So the distance that this ship has moved after t hours is going to be 15t. Then when we move east, this other ship, we can calculate its distance as well. Again, its distance equals rate times time. This one's moving 20 miles per hour for t hours, so its distance as a function of time is 20t. Now that we have all of the side lengths of this triangle, we can use the Pythagorean theorem to relate them. Remember that with a right triangle that has sides A, B, and C, where C is the hypotenuse, the relationship is A squared plus B squared equals C squared. In this problem, that's going to be 15t quantity squared plus 20t quantity squared equals our distance function d of t quantity squared. Now, on the left-hand side, we can actually square these out. 15t times 15t is 225t squared. And then 20t times 20t is 400t squared. And that is still the distance function d of t squared. Now we have like terms on the left that we can combine. 225t squared plus 400t squared is 625t squared. And that is equal to d of t squared. And then lastly, if we want to know what d of t is, but it's being squared, we need to take the square root of both sides. So we get d of t on the right. And if you take the square root of 625t squared, you end up with 25t. And we don't need to write plus or minus because we know that we're looking at a positive distance and that t is positive, so it's just 25t. And so this is a function that models the distance, d, between the two ships as a function of time. Just going to write it again over here. D of t is equal to 25t. This might be useful, for example, if we know that their radio can last a certain distance, and so we'll know how long it is before they're out of range of radio contact of each other.